Hey guys, welcome to lesson 721, day 2. Today we're going to learn about transforming the sine function graph, and this is exactly why yesterday we reviewed our a, h, and k and like the transformations with parabolas, because all of those rules that we learned back in the day, they apply when we are trying to graph transformed sine functions. The only thing is these come with a little bit of extra vocabulary that we're going to need to know. So A, H, and K, as you can see, are still in the spots that we're used to. It's just now we have a sign here. But A, while it is still in charge of stretch and compression, it's also called the amplitude for a sine curve. And we'll talk more about what these vocab words mean. H is a phase shift, which is still shifting left or right, just as usual. We're not going to deal with really phase shifting in this class, but it's a thing. And then K is still up and down movement, but now for the sine function, it's called a midline. So it'll make a lot more sense when we do an example what this all means. It's also still true that if there's a negative sign at the very front of your function, then there has been an x-axis reflection. So these are all things to keep in mind as we're going through here. So first, we are going to go ahead and graph the parent function of sine, and then we're going to see what happens when we shift it up 2 units. So when we're graphing sine functions, we're going to use something called like the 5-point trick, where these 5 points on the unit circle are the easiest ones to graph, and that's why we use them and focus on them. So let's go ahead and figure out what these 5 points are using the unit circle. Eventually you will and should have this memorized just from doing it a million times. So recall that all of these coordinates have sine and cosine values on them. When we look at each number in the parentheses, the one on the left is the cosine and the one on the right is the sine. So when I say sine of 0 radians, I look over here and I look at the number on the right. That's a 0. At pi over 2, I look up here where pi over 2 is, and I look on the right, there's a 1 there, so the sign is 1. At pi, on the right, there's a 0. 3 pi over 2, on the right, there's a negative 1. And at 2 pi, we're back at the same spot as 0, so right here, it's going to be the same. Right back at 0. So as you can see, these are very, very easy numbers to work with, unlike that ugly like root 3 over 2, root 2 over 2 stuff. So these are the ones we stick to. And it's convenient because it's also like our highest and lowest points and that kind of thing. So let's go ahead and graph these points on our graph. We start at 0, 0, which is right here. Pi over 2, 1 would be right here. Now keep in mind that we will always be skipping these pi over 4s. My Up in Math will always have them on the graph, but we're not going to worry about them. Just completely ignore them. Don't ever put a point with your mouse on a pi over 4 spot. The next one is pi 0, so won't go up or down. 3 pi over 2 is at negative 1, so I'll go down 1. And then 2 pi is at 0. So we can go ahead and draw in our curve. This is not going to be the prettiest, but that's all right. So this does technically go on forever and ever, so we can go ahead and put some arrows on the ends there. This is the parent function of sine. We are pretty familiar with it. And in the directions it did say to then shift it up 2 units. So we can literally just take all of those points and move them up by 2. So this one goes up 2, this one goes up. All of them move up by 2. Oops. Okay, each one just moved up 2 boxes. And you can just draw the curve again. Dang, I'm so close. Let's try again. All right, that's better. Okay, and so this then is our final graph. And if I want to write the equation for this graph, this is the final product, I'm going to want to look at this graphing form. Okay, this is what the general format is going to look like, so that's where we kind of just plug a bunch of information into. So let's put that down here to help us reference it. Y equals a times sine of x minus h plus some k. So when we're finding the equation, it's going to be helpful to us to find all of these pieces of information first. Now the midline is exactly what it sounds like. It is the horizontal line in the very middle of the graph. So in our original parent function, we were held between -1 and 1, so the midline is between those at 0. So here would be my midline. And then when we moved up by 2, the midline moved up by 2 as well. So now my new midline is at 2. Now after all, the midline is a line, so we have to represent it as an equation. It's always going to be a y equals some number equation. So the one that we're going to use is 2 because that's where my new midline is. We're not talking about the parent function here. All right, and the amplitude, I have a description right over here. It's the height from the midline to the highest point. It could also be considered the height from the midline to the lowest point as well. Those distances are the same. So really that's talking about this distance and this distance. You can see that there's just one box of space between those spots, so my amplitude is just 1. There is no stretching going on here. We just moved it, so 1 is the default amplitude. Just like how the default midline is 0. All right, so a period is how long it takes on the x-axis to complete one full cycle. So to go from 0 up, middle, down, and back to 0, to complete one S curve, it took us all the way from 0 to 2 pi. So that tells me that my period is going to be 2 pi. And again, this is the default period, unless if that happens to change, which sometimes I'll ask you to recognize, given a graph, what's the period. But when you're graphing, the period's always going to be 2 pi. So now that we have all this information, we're ready to create our equation based on this general format. So y equals, A is our amplitude. Now, here our amplitude is 1, so we have the option to write it or not write it. It really does not matter in this case because 1 doesn't change anything. This sine part is always going to be there. Like I said earlier, we're not going to be working with phase shifts here. We don't have an h, so you could put a -0 there if you want, or you could just leave it out. And then for k, same idea. The k is the midline. Right. So whatever the midline is, ours is +2, so we'll put a +2 here. Like I said, that amplitude is optional if it's a 1, but a lot of times we'll have a different number there and it would have to be there. The period is not represented here because it's just the default one. Okay, and we are done writing the equation. Now, like I told you a little earlier, there is a 5-point trick to graphing sine functions. So all sine functions are going to look something like this. Okay, here's our graph, and I'll just follow the parent function. If this axis is our midline, you always start at the midline, you always go to the highest point next, back to the midline, lowest point next, and back to the midline. All right, and it's always going to go by those 5 spots, right here, 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 and here. So as long as you keep that pattern in mind, it'll be pretty easy to just graph these as long as you know the midline and the amplitude. All right, so let's practice a little bit. So if I want to sketch the graph of 3 sine x, now let's just go ahead and write the regular parent function here just for our reference purposes. It always is helpful when you're doing this to list out what transformations are taking place. Now, there's nothing in the parentheses, so we don't have an h. There's nothing being added or subtracted on the outside, so there's no k. But there is an a. That's going to be our amplitude. It's 3. So we can write that. Our amplitude is 3. The midline, because there was no extra k, we could just imagine that it was a 0, right? Because the default midline is 0. So technically, if there's no k value there, it's just going to be 0. Y equals 0. Do not forget that y equals, otherwise it's not an equation and it will not count. Okay, once you have this, you are in pretty good shape to graph. for some people, it can be helpful to graph the parent function first, just so you have something to look at. And if that's you, I will show you how you can go about doing that. Eventually, you memorize the parent function and how to graph it, because, again, that's something you end up doing like a million times. So if this is my original, trying my best. This is my y equals sine x graph, the original, untouched, unchanged graph, and I just took it and I stretched it by a factor of 3 with this. And that made my amplitude 3. So in my original, I have a midline of 0. That's my default midline, and as we just discussed a little bit ago, that didn't change because I don't have an extra k value. So now we just need to follow the 5-point rule. You start at the midline, you go up high, middle, down low, middle. So let's follow that exact pattern. You start at the midline, up high. Now this is where the amplitude comes into play. If the amplitude is 3, that means your highest point will be 3 boxes away from the midline. So I'll go from the red line, I'll go 1, 2, 3, and plot my point there. Okay, then I go back to the middle based on this. My next point is down below. So just like how the highest point was 3 away from the midline in the positive direction, my lowest point will be 3 away from the midline in the negative direction. So 1, 2, 3. All right, and my last point, if you look at my 5-point pattern, ends up right on the midline. So now that I've made my dots, I can draw my curve. Oh, that was really bad. We're just going to go with that. All right, and this is my final graph, and it was just stretched out a little bit compared to the original one, particularly by a factor of 3. All right, so now for the next one. Now this one just has one itty-bitty transformation, and that is the negative sign up front. What that means for us is that we are going to have a reflection. An x-axis reflection. All right, so let's go ahead and draw our original function so that it'll be really easy for us to reflect it afterwards. So these I'm just going to draw pretty fast because, again, they're very basic sine curve. And they don't have to be perfect. Now, on my open math, when you actually answer these questions, don't actually put this original one on there. So when we reflect it, we will simply take all of these points and reflect them over the x-axis. So if this is our midline, of course the midline hasn't changed. I'm going to pause recording because I'm running out of time. And look at my points. The ones on the midline won't move, but the ones above will go 1 below, or however many the amplitude is. 0 again doesn't change. 1 below turns into 1 above, and 0 doesn't change. So you can draw your curve. And this is my final graph, the blue one. Okay, just a flipped version of my original parent. All right, I have one more example, and this one is consisting of us writing the equation. So looking at this graph, we have to figure out all these pieces. Always start with the midline. That's going to be the easiest one to find. It's going to guide you in all the other parts. So you can tell that the highest point is at 2, and the lowest point is at -2. Okay, so the middle between -2 and 2 is going to be 0, and that's how you figure out where your midline is. You just find the spot right in between the highest and lowest points. So we can write y equals 0 for our midline. The amplitude is the distance between the midline and the highest or lowest points. So right here, there's a distance of 2, so my amplitude is 2. We can tell that it was reflected because the original sine curve goes like this, but a reflected one goes down first. So this is a big yes. So now we can write our equation. Let's write the general for reference. All right, I've matched these things to where they go on here. Oh, this is a mistake. To change that to a k. So you end up with Y equals 2 goes first. Sine of x, there's no h, and then the k on the end is 0, so we don't need anything there, but you also need a negative sign.